Today we're going to talk about another way to divide polynomials. But before we get to that, I just want to go over some vocabulary that we're going to be using a lot this chapter. I just want to make sure you know what it is. So a monomial is an expression with one term. Expression with one term. So maybe something like 3x squared. Okay, that's a monomial. There's only one thing. If it were 3x squared plus 1, that would be a binomial because there's two things. Or 3x squared plus x plus 1 would be a trinomial because there's three things. Okay, a polynomial is an expression with many terms. So, for example, 4x to the fifth minus 8x cubed plus 9x minus 7. Okay, that's a polynomial. So we call it a monomial when there's one term, a binomial with two terms, a trinomial with three terms, and then once we get past trinomials, we just call it polynomials for many. The coefficient is the number in front of the x, or whatever the variable is. So the coefficient there is 3. We just talked about a polynomial. The terms of a polynomial this is the first term, second term, third term, fourth term. I don't think I really need to write a definition for that. Terms are split by a plus or a minus sign. Okay. Now, the degree of the polynomial is the highest exponent. So this polynomial up here, this whole thing, would be degree 5, okay, because the highest exponent is x to the fifth. And then standard form of a polynomial is when it is written in descending order. Of the exponents. You are really used to that. Okay, this one is written in standard form because it goes x to the fifth and then x cubed and then the x and then minus 7. This polynomial 8 plus x squared minus x is not written in standard form. Okay, so you'd have to rearrange it. So that's not standard form. Okay, so those are just some vocabulary things that we're going to be talking through. One other one that we might mention is leading coefficient. Leading coefficient would be this first number here when it's written in standard form. All right, now we have been talking about dividing polynomials. So if we want to take 8uv plus 10uv squared w minus 8uvw, that's a lot of stuff, divided by 2uv. If you're dividing by a monomial, you don't have to do long division, okay? You can just split this up. You can just take all of these terms on top and divide each one of them by 2uv. So we can split this into 8uv divided by 2uv plus 10uv squared w divided by 2uv minus 8uvw divided by 2uv. Okay, this only works when you have a monomial on the bottom. And then we can simplify these things. 8 divided by 2 is 4. uv and uv are going to cancel out. Plus 10 divided by 2 is 5. The u's cancel. One of the v's cancel. That one cancels, and so we're just left with 1 on top. And then w minus 8 divided by 2 is 4. uv is going to cancel, and you're just left with w. Okay. So if you're dividing by a monomial, you can do just a real quick, easy way, split it up, divide everything by that monomial. What we talked about before with dividing is if you're dividing by a binomial or a trinomial or anything bigger, we were using long division for this. I don't know if I have enough room to get this in here. What if I do it this way? I think I can maybe squeeze it in here. So we're going to 2x plus 3, and then over here I'm going to do 2x squared minus 17x minus 38. Okay, so ignore that now. Okay, so we're going to divide this. Remember, our goal was to get the 2x squared, so we need an x on top. So that gives us 2x squared plus 3x. Draw the line and change the signs. Drop the negative 38. Our goal is to get a negative 20x, so we'll need negative 10 up here, which gives us negative 20x minus 30. Draw the line and change the signs, which those cancel, and we have a negative 8, which I do not have space to write. So we have a remainder of negative 8, which remember comes up here, minus 8 over 2x plus 3. I apologize for space issues on that. So that's long division. There is a shortcut for long division. Yay. It only works in certain situations. It actually does not work for this problem because it has the 2x cubed. So this other method only works when you're dividing things like x plus 3, something like that. But I will show you that. So let's check it out. It is called synthetic division. So again, it only works when you're dividing by something that has a leading coefficient of 1. Otherwise, it doesn't work. So here's the setup and the steps to it that are on your notes. The steps are a lot more complicated than what it actually is. So we're going to write the coefficients of this term. So 1, 10, 18. If you skipped something, just like in the long division, we'd need to add zeros. We haven't here. We're going to write, put a little box here, and we're going to put the opposite of this number in the box, so negative 5. Okay, and then we're going to draw this little line here. This is the setup, okay? For some reason that 10 looks weird to me. Let's fix that. Okay, so what you're going to do is drop that first coefficient. We're going to multiply negative 5 times 1. Little dotted line, and you're going to write the answer up here. So negative 5. Then you add these numbers. And then you multiply negative 5 times 5. You write your answer up here. And you add those numbers. And that's it. Okay? This is actually the answer. Now, so that was repeating until finished. We call this thing a depressed polynomial, okay, a depressed polynomial there. We started with an n squared. Our answer is going to be 1 degree less. So instead of an n squared, it's going to be n to the first. So our answer is 1 n to the first plus 5, and then this last term is the remainder. So minus 7 over whatever we divided by. Okay, and there's our solution. Okay. Synthetic division is way simpler because you're only multiplying and adding, and you get to do the long division without actually doing all the long division out. So I'll show you some more examples in the next video.